All right, so we'll be on air now. Hello, everybody, and welcome back. Last week we did a little bit of meta programming, and I will dive a little bit further into this topic today, just because I think it's quite interesting, and especially it probably broadens your view about software engineering in some way. At least that's what I hope for. Whenever you feel I'm too fast or too confused or whatever, just let me know and tell me to go into more details if necessary. I can even see the chat, so if you don't want to talk, you may just type. Yeah, last week, quick roundup. So I have to this button. No, this is the wrong button. Which is the right one to bring the button? Okay, so no, I'm away. I'm afraid. Well, it's not that bad, but I pushed this one before. Pip source. Ah, I got it. Yeah. So what we did last week, we refactored all the standard CRUD controllers to contain next to no code by moving everything into the CRUD concern. This CRUD concern is a module that's being included into the application controller. And we have this method CRUDify that takes care of, well, dynamically programming all the CRUD actions in a way. So in the books controller, we just say CRUDify and give the attributes you want to see in the index view. We tell which methods to actually create. This is done by selectively including the correct modules that contain the implementation for the desired actions. So for the destroy action, we include the module CRUD concern destroy action, which will then be a generic destroy implementation. I think it might be reasonable to have a brief look about the basics of this class hierarchy stuff. So I just go to the interactive Ruby. So whenever we have some class, so the simplest class, or it's not really the simplest class, but in a way. So object is the base class of everything that's reasonable. And we can ask every class about its ancestors. And this gives you an array of the objects that are parents of object. So in this, the classes that are parent of object. So in this case, it is object itself by convention, then the class kernel and the class basic object. And basic object is really the obviously the most basic thing you can think of. And if we have a look at, for example, let's say string, and look at the ancestors of string, we see that string mixes in the comparable module, so you can compare strings, not too surprising, and then object, kernel, and basic object. So for almost everything you look up, you will find object, kernel, and basic object to be the three last members of the ancestors list. And so whenever you have something like, or if you want to know whether something is a subclass of something else, you can always ask whether, for example, string is subclass of object. This will be true. And this should be true for kernel. Oops. And basic object and so on. So you can find whether this less than for the classes really just means it is the right one in the list of the of the ancestors. And what we used last week is this include thing. So the most basic example, if we have a class A, which contains no implementation, not interesting, and we say we define a module, module B, define a function here, and this is just returning I am from B. And we then say a.include B. Oh, we should do that on the command line. And we then define a new a.new, then A has this method F that comes from the module B, and ancestors is a B object and so on. So implicitly, if we just define a class without specifying a superclass, it is always just object. It really just, we could always explicitly say object, but this is just not, yeah, doesn't really help, so we omit that. Okay, but there is another interesting thing, that is we define a module C. This has some other method, let's say G, and this returns I am from C. We define this. And when we then say a.prepend C and ask for, so first we can just say a.g. This is still working, although the definition of G was beforehand for the method lookup. The current state of the base of the defined of the defining class is used. So although we included the C thing later, it can still be found. But if we say a.ancestors, we will find that C is in front of A. So B was included and C was prepended. So every definition that is in C will take priority before function definitions that come from A. So if we just close the session and start over, so we now define a function f here. I am from A, and f is and g. So now we have this function f being defined in A, B, and C. So we first only define the classes or modules, and we get a new a.new. And if we ask A for F, this is from A. And if we then include it will still use the definition from A, because, as I said, a.ancestors. The method lookup goes from left to right, and we first have a look at do we find the method in A, and we found it, and so the definition in B will just be omitted. But if we now say a.prepend C and say a.f, the method definition from C will be used. This has the interesting effect that when we so if we include so let's just say we call this the super keyword in Ruby is slightly different from the super keyword as you know it from Java. It doesn't mean something like the super object or the super class, but it refers to just call the same function with the same parameters uphill in the anchor stat chain. So if we do define f like that, oops. And again, we say a is a dot new. And if we call f on a, this should just fail because there shouldn't be a definition of f uphill in the anchor stat chain. So bam, no superclass method, f for a. But if we include b, I should probably define b before. We can include it. Now we have this definition, and this super call from a just works. And since C, if we prepend C, we can call the super means that we can use the super of the class that we are prepending. So it's a neat way to tweak actual implementation without subclassing. So we can say this plus super, for example. So we define this module C, whoops, and say a.prepend C and a.f. I am from C and I am from B. And this implementation of A is really just the call from super, but this is the way the method is called. So it's the first thing that's being executed is this, then that, and then this from B in the end. This is how we can change the we can. Oh yes, I'll explain that. So we can decide how to or where we insert a method definition. A module. So first, a class is something that you can instantiate. So a class is really pretty similar to what a class in Java or whatever, probably not JavaScript, but any other language, is. A module is, so modules are slightly more stupid than classes. So you can't have an instance of a module. So we have this module B, but you can't call b.new. It's just not implemented. So this B thing is, or modules are the basic thing of objects. So if we say of classes, so class.superclass, we find that classes themselves inherit, or the class inherits from the module class. All right, and modules have two main purposes, or three. First, they are used as namespaces, so you can just have a module, and you can have a class D inside this module. The same is true about classes. You can have classes inside classes, but this is quite frequently used. So you can use modules just to create namespace hierarchies. So to access this class D, the full path would be BD, because D is a constant of the module B. This is the first thing. The second thing, modules can contain class or function definitions that are used to mix as mix-ins, and that you can introduce into different classes. For example, enumerable, comparable, and quite a lot of other standard library code things are modules. It's in this case a little bit like when you come from a Java perspective, it's a little bit like an interface that contains implementation that you can mix in later. So in Ruby, everything is dynamic, and so you don't have to decide from the very beginning what to include, but you can include stuff later. Yeah, and the third thing you can do with modules is you can say, call this foo this time, and we define a function with self.greet. Hello. You can use modules as a container for static functions. So foo.greet can just be called. So if you have functions that you just want to collect in some bag, you can use modules as these bags. What you can do too, you can't just what we did in the upper part is we used modules to add instance methods, but modules can be used to add class methods too. So just restart the Ruby there. We define, oh yes. Yeah, just for shits and giggles, we define our function, our class A. We define the module C. And now we say a.extends. See, I always not sure whether it's extends or extend. No, it's extend. Ah, yeah, all right. So now we can call a.f. So we added the implementation. So the functions that come from this module are being added to the class itself. So this f is not an instance f, but a class f. And this is done by this extend thing. And quite common pattern that you might see pretty often when you look into the Rails code, for example, all these concerns are made like that. We define a module. It's again called C, and this contains some function G from C. This is F from A, just to be. And as you probably remember from last time, we can define a function included by. And if we say a dot include b, this function is being called with a as the parameter by. And if we decide we want not only to add instance methods, but also class methods, we can define another module here called class methods. Although we could call it however we like. It's just a convention to call it class methods. CFGH. And this is then H from C class methods. And we can then say here by.extend class methods. So including C into A will call this included by, and then implicitly add all the methods defined in class methods to the class A. So A should have an H method afterwards. You can just check this. Kaboom. And Then, oh yeah, we called it C. Probably restart, because and then a dot include C, and then a should have this h class method that comes from the C class methods, and this was introduced by calling this extend. So you can not only add instance stuff, but you can also add class methods. This works for modules too, by the way. And we had a class D. Or we will use the methods of class D. There's a question in the chat. If I write A prepend B and we had a class D inside module B, will A use class D or A will use the methods class D? So I don't really understand it. But so having whatever modules contained in another module doesn't change anything about the class Ancaster chain. This is really, so when you put a class into another one, or a module into another module, or class into a module or whatever, this doesn't influence the method lookup. This is really just kind of namespacing. But what's important to notice, probably, so if we have a module A, so we close this, we have a module A, and for example, a constant here. Let me call this constant name equals to IMA. And we have another module B inside, and a function get name, and it will just return name. Oops, name here. Then the constant lookup will bubble up in this. So this is not a. This is more like a scoping, not like a inheritance stuff. So if we say b dot get. So of course, first of all, b is not defined on top level, but it is part of a. But if I say a colon b, so colon is used to address constants of whatever. So anything that you try to access with a double colon is must be a constant. And so this name comes from here. This might be a little bit, or you might run into slightly strange situations if we defined stuff like this. So we just say module A, name is whatever, and we then say module A colon B. Then this lookup doesn't work anymore, because this is something, this lookup is something that is done with, yeah, as I said, with it's more like scoping. This again, first define our module A, and then define our module B, or A colon B. Get name. This should not work. Yeah, merp. So in this case, you'd have to explicitly access it by saying, I want this A name constant. Yeah, something you just have to know that. So constant lookup is something that is not done, or this scoping, when you have this kind of hierarchy of classes, this is something where you have really quite explicit scoping. Okay, I hope this answers the question at least a little bit. Okay, so yeah, this is really just something I wanted to show to you for you to get an idea about what is possible here. I guess we don't use this. Yeah, generally, you rarely use stuff like this really explicitly, but it's just quite helpful to know about it. What I want to do today, in fact, is for the I think the books were the more interesting ones. Yes, for the books controller, I thought it could be neat to say we want to implement a show action. Simplest thing is we have this index attributes, and we add show attributes. And yeah, we just use the same ones, at least for now. This will not work, of course, because we have to add this show attributes stuff into the application controller here. So index attributes and show attributes. This is generally empty. Okay. So if index attributes, we can do the same stuff with show attributes. Define method, show attributes names, show attributes. I will say some words about define method in a moment. And yeah, we can just run the application, Rails S. Okay, and we forgot the. No, this is neat. We can, yeah, we forgot the link to the show action. Actually, we didn't implement that, so we could now either go to the generic index thingy here, and say we add whatever happens before, we add another one, another column, and this is a link to. So how did I call that? I'm just going to. No, well, easiest is to just say we just link to object. This will work because we don't use any namespaces here. Link to show object. Merp. All right. So here we go, and we can now look at the show view. But this is explicitly implemented still. So this is not. This doesn't currently use the show attributes we defined before. So we have to define a new view for that. Call this show HTML slim. And this lives in application, and so in the books we can remove the show. Delete file. Whoops. Just see, this should be 2 question marks. So yeah, and we now, in pretty much the same way we did things for the listing, we can now create a show view, but of course we don't need a table. Just do DL. And index attribute names, so it's show attribute names then. Yeah, DL minus show attribute names, each do num, and dt is num. Oops, this is strange. And dd is I think it's current object. I always forget that. So on the CRUD concern, oh yeah, it's the current object. Current objects. Yeah, current object. Current object send name. Merp. Show attribute names. And I forgot to make this a helper method. So index attributes is, so where did I define that? Just to make things consistent. So this index attribute names. Okay. So we have to add this as a helper method. And now it works in principle, at least. It looks ugly, but still works. So the author is this, the title is that, the pages is that. And if we go to the books controller and probably just, for example, just remove the pages should just vanish here. But what if we decided that we want to have the title to be typeset in a somewhat different way? For example, if we want the title to be fat or uppercase or whatever. So we could, for example, define that we accept something else. We accept hashes here. And so we have author. No, it's a title. And so what is the correct right-hand side? So we want to somehow modify the input, so we can make a closure and say we give back. So this is a nasty way of doing things, but we can still do it. And r.name in here. r.title. So now we have two different kinds of attributes. The first is just a symbol, which will be used as both the label and the method to be called. The other is a hash that has the label as the key and a closure on the right-hand side to define how to actually render the object or the string. So we go to the show view. And now this becomes slightly more complicated because we have to say if num, it's probably easier to completely split this into two. If num is a hash and otherwise we stick to what we did before. Then k is num first. We can directly say k dot so we always think, or we expect this hashes to oh no, it's probably no. Let's just say we iterate so we can add more into one hash. This is just neater. So we can say num.each do and key value. Okay. So what do? We do we say dt equals to k. So we just consider this to be some key that we just print. And for the right-hand side, for the description, we expect v to be a closure. So we call it with our current object as the parameter. So let's see what happens. We have an error. Encountered a syntax error. What did I do wrong? Probably add an if here. Okay, so well, this is probably not exactly what we wanted, but it's already getting close, because at least we are able to somehow modify our right hand side. So this, well, we could, for example, say HTML save, HTML save. And then it would be neat. But of course, if in the title of the book there would be any HTML markup or JavaScript or CSS or whatever you like, it will just be printed there. So this is definitely a security issue. But yeah, just to get an idea, it is quite okay-ish, I think. Although this is not the way this should be done in Rails anyway, because we normally or we correctly say this is content tag, and a b, and the value inside the content tag is r.title. Yeah, this is correct now, and this even does the correct escaping. So if in the title there were any HTML tags, they would all be escaped, and you'd have them replaced by greater than and less than things. Okay. Sorry. So, another thing that we could come up with, just add some line breaks to make things more readable. We could come up with the idea that instead of just writing it, we want this to be a link to, and the first parameter of the link to is the name in fat, and the value is something like some search whatever. Yeah, probably it wouldn't work like this, but yeah, just to get the idea. Undefined method. All right, so it didn't work before. It just was I've just been too fast. I was surprised. So we just roll this back, so you can see the problem. So content tag is not defined in the current evaluation context, and this is what's interesting. So where do we define this this closure? I was surprised it worked before. This closure is being defined in the context of the books controller, not even in the context of an instance of the books controller, but really in the context of the books controller itself. Because, yeah, when the method gratify is being called with some parameters, and the parameters, yeah, they just live in wherever they are defined. So in this case, so self here would be books controller. So the class books controller itself. All right. Can't stress this enough. And although probably a books controller instance might implement content tag, the books controller itself does not implement it. But this is the right way to do it, to some extent. So what can we do? We'll just put a debugger here, so we can see what's actually going on. So we're reloading, and now we're on the debugger. So K is title, and V V is a proc. And it was defined in the books controller at line 5, but procs are is the class of the closures. So when we say v.call with current object, yeah, it doesn't work because content tag is not defined in the books controller class. This is what the problem we had before. But what is self here? So the debugger stopped in this line. So we are currently evaluating the show view. So self should be something like action view. Yep. So we have an instance of action view base. This is where we're currently living. And we could, for example, content tag is working quite well here. So what we could do, if we can, is try to evaluate this closure not in the context it was defined in, but in the context we are currently in. And this is possible in Ruby. And it's, instead of calling this V, we say instance exec V, which is the closure, and the current object. You can try that in the command line. Yeah, we have to blockify it. Instance exec executes a block and gives the yeah, I will just put it correctly here and then explain. So instant exec takes the parameters, in this case this is really just current object, and passes them to the evaluation of the block in my context. So this block, and by putting an ampersand in front of a closure, we can turn it back into a block. This closure is being evaluated not in the context it was defined in, which is lexical scoping, which is the way things normally go. This is the way we all think normally. But we are with instant exec, we kind of turn this into dynamic scoping. So we just change the evaluation context of the block, take it out of the books controller where it was defined, and evaluate it in another context, namely in our self. So instant exec is being we execute this in the context of the current view. So this is self. Yeah. And if we now reload this thing, yeah, and quit the debugger, we see everything's working. Just remove the debugger here. And this gives us the chance to, yeah, inside the controller. By the way, you might think this is exactly what this says that we should never do. But oh yeah, so this is this U model 999. I think that in general, of course, you should never put view code into your models, but at some points it's just neat to be able to add some simple enrichments of strings in the controller. And for example, in this case, this enables us to produce extremely concise code and make things very, very short. And so, yeah, this is still neat. I still like it. Okay, so by using this instance exec, we are able to evaluate this closure in a different context. This does not mean changing the binding. So if this closure relied on any local variables, these would still be there. So, for example, we have a function f. And we say x equals to 1. And we return a closure that's just returning x. Yeah. So this will just return a proc or a lambda. In fact, I won't go into this detail now. That's just returning the value of this local variable. So let's try this in the command line. So f produces a lambda, and if we just call this, we get 1. And now we think, oh, well, you can just define x to be 7, and now f should be 7, obviously. Nope, because it's still the proper scoping of variables is not changed. So the scoping of the variables is still lexical as you would expect it. And if we said, yeah, but now we could think, well, yeah, so if we just instance exec f in ourselves, so here x, the value of the local variable, x is 7, so we can just say self dot instance exec f. Yeah, I should assign it. So now ff is this proc. Self instance. It is still 1 because at the point where the this closure was defined, the local variable x had the value 1. So if we do things like this, then this x is not a local variable anymore, but it's a function that's being called on self. So if we instantiate a and get and call f on it, just restart it. A is a.new, a.f. This returns the proc, and we then call the proc. It will be 1. But if we now say we produce a class B, that has a function x, which returns 2. And we say, we define this class, B is b.new. And again, we assign ff to be this proc given from A. And if we now say b.instance exec ff, now it will be 2, because what we changed, so this is not a local variable anymore. This is important to notice, but this is a function call. And by changing the evaluation context, the function lookup is being changed. So what's being changed is what self. Yeah. So this to some extent, the explicit and implicit keyword self is being changed by using this instance exec stuff. Slightly brain twisting, but once you get used to it, it's quite neat. And there may even be situations where you can, where you have to assign a local variable because you want to be totally sure that the value does not change by instance evaluating in some other context. All right. I do admit this is brainfuck. Another thing I wanted to point out, we have this index attributes thing here, and we see what we are using here is define method. So if there are any instance attributes being given, we define a method instance index attribute names to be the list of these index attributes. And as you see, this is done using a block. So we define method takes one attribute, the name of the method that should be defined, and a block that is then later the body of the function. Sorry. As you see, this is using the local variable of the outer context. So this block is being lexically scoped, blah, blah, and it uses the local variables here, which means that the memory frame that this is running in must be preserved, because this is where this definition comes from. So the memory frame of the credify call must not be dropped, because you're using this for to access this index attributes thing here. This is generally not a problem, because what is this this memory frame? It is in the books controller. So it is this, yeah. So this is the context here. But in general, this is a way where or this is something how you can rather easily create memory leaks. Because if the context stuff is defined in is very complex, it is just it's just bad to being able to have it survive every reload and everything, and you have to really keep it until forever. And this is one of the reasons why when you look into bigger Ruby libraries, you often find they do not use define method. But what they're using quite frequently is they're using class eval. And then they are just evaluating strings. So just do this. By the way, I don't think I introduced these here doc things. This is a way to define a multi-line string. So you this Ruby is an arbitrary string. You could have anything here. Whoops. And all lines that do not contain this string will be considered part of the string. So this is the start and end marker. And you can put anything you like here. And yeah, so this is just a long string that may contain new lines. But if you put a Ruby here, the syntax highlighting of the editor will know how to deal with it and how to syntax highlight. Although we are in a string here, but from the perspective of the syntax highlighter, it's being dealt with like like it is in a Ruby code, yeah. Okay, so, and now we have to, yeah, of course we have to somehow put the index attributes here, because we want to give them back. But this might not work, because just by using interpolation, this may just go pretty wrong. We will see. So this even worked. We add some, just to be sure that we can properly see that. All right, so this index attributes thing was called properly because all the columns are defined as we want them to be. So this just surprises me a little bit, to be honest. Yeah, okay. Yeah, so it works. Although this is yeah. What happens here? So now we produce a string. This is really just a you can just assign it probably. This is really just a stupid string. And then we evaluate the string in the context of the class. So we're reloading. Close this. We're reloading here. Yeah, so this is the definition, or this is the string that we are then evaluating in the context of the class. This is, of course, a somewhat dangerous thing to do, and you should never, ever do this with any user input. You should never use any user input that you didn't extremely well sanitize and evaluate it. But all stuff that comes here was written down by a programmer anyway, so he could just, or she could just break the code themselves. So this could be, yeah. So of course you should do some sanitizing stuff, but in general, it's not much more dangerous than just than using this define methods thing. One thing that's bad is if there was an error here, so we just add an explicit error, we're reloading. And if we look at the trace, yeah, this is not this doesn't really help you a lot, because it is just in an evaluation. So this index attribute name produced an error in an evaluation context. You don't get the correct line numbers. This is sad, because you always should know where the error comes from. So what we can do, so this putting stuff into a string was really just for demonstration purposes. We could add more parameters, namely file and line. These are constants that are available in every Ruby file, and they just give you the name of the current file and the line number of the current line. Not too surprising. So if we're reloading here, oops, we see that the error comes from app controllers application controller line 7. Here we go. Although this is not completely correct, because we'd have to add one line, because this line is this line, and we wanted to know that we are on line 8, so not on line 7. Okay, so now we are at the correct error position. Yeah, so this gives us a chance to make the error handling quite neat. And funny enough, it really looks like you're looking at somewhat proper Ruby code that's really just implemented. Although, in fact, the code is being evaluated in the context of the class. By the way, when you're using these HereDoc strings, and they can be quite handy for adding smaller CSV files inline or whatever you can think of. Any further parameters are just being added behind the start marker. So you'd probably expect this to be more like, okay, if you want to add more, you should have to add it here. But this is really just not the case. But you have to just stay behind the marker. It's again something that I should probably just show you, again for shits and giggles only. Define a function f, as always, string 1, string 2, and number. And yeah, this is really just puts 1. Oops. So when we have this function here, so what we say about, and this works as expected. But if we want to use HereDocs there for this thing, we can say f of a, b, and 6. And we add some stuff for A, and we add some stuff for B. So you can even have several of these HereDoc strings in the same call. Every now and then, even the syntax highlighter of the editors get into some trouble with stuff like this. It's not frequently used, but it's just yeah, good to know how it works, because every now and then this might come handy. All right. So are there currently any questions about what I did so far? Nobody has the camera on, so I really don't get any kind of feedback. This is quite annoying. All right. So yeah. Thank you, Christoph. Adrian, this is very nice of you. Yeah. Okay. So this is what we did here. And of course, in this show controller, we could or what we normally have in the show view, we have the edit and the back to the list. So link to edit is quite easy, because we can just say polymorphic path of edit and current object. This should be working after restarting the server. And we should remove this intended error. Merps. So we go to show, merp, and we can click on edit, and this works. All right. So, but what about the link to? Yeah, I just call link to index. How could we do this? Well, we don't have a proper way to address the current index path, because this is something we didn't implement here. In the Cradler stuff I showed you last week, I have all helpers for current this path, current that path. But when we look at the CRUD concern, we see we have this. Oh no, we even have the current index URL, so we can use it. This is neat. Current index URL. Merp. Undefined. No, it doesn't work. Why not? Because it's not defined as a helper method. Why dot current index URL. Merp. And we can go back to the books and show and edit and stuff. What we'd like you to do for next week, or as a exercise for next week, is adding where is it? Books controller here. What we did with show here, add this for edit and new. So create a generic edit and new views that are using all just generic code, not any specific books controller code, but really just add what's necessary to make this CRUD concern and this CRUDify stuff work with new and edit too. The actual implementations are already there, I think, but it's really just the view stuff that needs to be done. Yeah, so some swearing isn't too surprising. So, but I guess you can do that. Did you write anything in the exercise already on the blog? All right. Okay. So we'll specify a little bit more what exactly we want you to do there. But this is the core idea. And again, this of course is not the way we are really doing things, but it's just to get an idea about how things can be done in this context.
And when you're searching for errors in libraries, when you're using some kind of library, you may encounter things like that.
Yes, quite a lot. So this is one of the, you probably heard of David Heinemeier Hansson, who's the inventor of Rails, and he's a quite controversial guy. He's well, he's not all good, but well, yeah. But one of the really very right things he said was that to learn using whatever language or whatever library, reading the code of others really helps a lot. And this is very true for Rails to get up and running and to understand how things are actually done. So if you encounter something, even things like belongs to or has many, just checking out the library and look where it's defined and how things are defined really helps you understand quite a lot and gives you much better idea about how the all this Rails ecosystem is being wired on the inside. Okay, so but now I forgot what I actually wanted to do. So this is where we were. So I'm completely lost now. No, no problem. It's my fault, I guess. So where was I?
We're talking about what they do for homework.
Yeah, about this homework thing. Do you want to say something about this bucket stuff, or
I'm not sure.
Christoph doesn't dare to come into the camera view because
Yeah. I think the credential I posted in the Discord should work. Yeah. So S3 bucket config.
So yeah, so there should be a free S3 bucket like thing available.
Yeah.
So you don't have to use your credit card, or you're not a credit card.
And if you don't get it up and running till tomorrow, it's okay.
Yeah.
So just try it, and if it don't work, just deploy your work without working active storage. There was a second question about the letter opener.
Yeah. So for this letter opener stuff, I think we last week already we said that it is sufficient if you just create a user, or probably two, and you give us the login credentials so we can check that, because if the mails can't be sent currently, so this is really not a problem. You can, but I think this letter opener web thing can be used to just if you omit the delayed stuff, you can just use that to simulate sending emails. This should be fine too. So this is okay. And anyway, in the end, we just want to have a brief video explanation how you did things, and or a walkthrough, and this will be the main grading basis together with the code. So it's not important that we can actually use this in all detail. Another thing, I think I already, or you could probably now stop the recording, because this is not, this is more technical, so we can just stop this.
Anybody listen?
I don't know.